Hi students, welcome to my class. Today I am going to tell you the best chapter of intermediate, or you can say your class 11th, which is Matrices. Yes, it is matrices. Today I am going to explain these matrices important formulae which are very much useful for Z-mains and also for your board exams and also in any competitive exams. I am also adding all the chapters important formulae and the main important topics for Z-mains. So don't forget to like and don't forget to subscribe my channel, students. Okay, let's start the video. Okay students, first in this chapter a basic formulas, what are the basics in the JEE matrices chapter. So now we will discuss the most important topics in matrices and also all the long ones. Okay, the first one is a diagonal matrix. What is a diagonal matrix? A square matrix in which every element is equals to 0. What is that? Every element is equals to 0 except whose principal diagonals of a matrix, except those of the principal diagonals of a matrix. That is a matrix. This is a matrix A 0 0 0 0 B 0 0 C. What are A, B, C are called? These are called diagonals. Diagonals of a matrix. Diagonals of a matrix. If these are if A, B, C places are numbers or exponentials, and all the terms are zeros, that is every element is 0 except the principal diagonal, so this matrix is especially called diagonal matrix. What is it? Diagonal matrix. This is the most important matrix. Okay, next we will jump on to a square matrix. Okay, what is the next one? It is a square matrix. Okay, now let's tell what is a square matrix. A square matrix is said to be a scalar matrix. What? A square matrix is said to be a scalar matrix if all the elements in the principal diagonal are equal and other elements are 0. Okay, a square matrix is called a scalar matrix if what? If all the elements in the principal diagonals are equal. You know that what are the principal diagonal elements? A, B, C. These are the principal diagonal elements are equal. That is A is equals to B is equals to C, and other elements should be 0. 0, 0, 0, 0, 0, 0. We can also write this matrix, that is a square matrix is called scalar matrix, in the form of A 0 0 0 A 0 0 0 A. Okay, we can also write in this form because A is equals to B is equals to C. Okay, now we will see another important point in matrices, that is a diagonal matrix in which all the elements in the principal diagonal are 1 and the rest is 0 is called unit matrix. Okay, our next important point is about unit matrix. What is unit matrix? Principal diagonal elements. You know what are the principal diagonal elements? That should be 1 and rest of the elements should be 0. This is called what? Unit matrix. If the diagonal elements are equals to 1, that is diagonal elements should be equals to 1 and other elements should be 0. This is called unit matrix. Next point is a square matrix is said to be a idempotent matrix if A square is equals to A. Now we will check the conditions for a square matrix. Okay. Conditions in square matrix. Conditions in square matrix. Okay, conditions in square matrix. Now we will see this heading. Okay, what are the conditions in a square matrix? Okay, first condition is a square matrix is said to be a idempotent matrix. Idempotent matrix. In this specific video, I am just explaining the important formulae and also important points which are related in matrices for JEE mains and also common entrance tests. If you want a detailed video about matrices, you can just ping me in the comment section. I will give the most detailed video of matrices with important definitions, with important formulae and more. So just if you want, you can put in the comment section. Okay, what is an idempotent matrix? What is unit matrix? With definitions I will explain now. If you want, just keep in the comment section. Okay, let's continue. Idempotent matrix. What is idempotent matrix? A square matrix is said to be a idempotent matrix. The condition, if the condition satisfies A square is equals to A. A square matrix is called idempotent matrix when A square is equals to A. And a square matrix is also called involuntary. These are most important for JEE mains. This type of matrix is idempotent matrix, involuntary matrix, symmetric matrix, skew symmetric matrix, okay, nilpotent matrix. These are really very important for JEE mains. Okay. Now, involuntary matrix, a square matrix satisfies involuntary matrix if A square is equals to I. You know I, Nana? I means 1, 0, 0, 1 in 2 by 2. If there is 3 by 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the form of I in 3 by 3 and 2 by 3, Nana. Next, a square matrix satisfies symmetric matrix. What is that? Symmetric matrix. A square matrix satisfies symmetric matrix if A is equals to A transpose. A is equals to A transpose. A square matrix satisfies symmetric matrix if A is equals to A transpose. What is A? 1, 0, 0, 1. Suppose this is A example, Nana. This is our example. If A is equals to, then A transpose is equals to 1, 0, 0, 2. Okay, same now. So A is equals to A transpose. This kind of matrix is called symmetric matrix and also called square matrix. Okay, next. Another point is about skew symmetric matrix. A square matrix is also called skew symmetric. Skew symmetric matrix if the condition is A is equals to minus A transpose. That is, here the negative sign and here is a positive sign. That's the difference. Nothing is changed, Nana. Here skew symmetric matrix. If A is equals to A transpose, then it is called square skew symmetric matrix. If A is equals to minus A transpose, then it is called square skew symmetric matrix. That's it, Nana. That's it about the square matrix conditions. Okay, now we will jump to another point. A square matrix is said to be nilpotent matrix. What is that? Nilpotent matrix. If you want this detailed video, you can comment, Nana. I will keep. A square matrix is said to be a nilpotent matrix if there exists a positive integer n. So, if there exists a positive integer n in the form of a power n is equals to 0, where n is the index of nilpotent matrix. What is n here? Index of nilpotent matrix. Index of nilpotent matrix. Okay. Next, our important another point is if A is a given matrix. What is the important point? If A is a given matrix, every square matrix can be expressed as a sum of the symmetric and skew symmetric. Every square matrix, what is that point? Every square matrix can be expressed in as a sum of symmetric and skew symmetric matrix. Okay, skew symmetric matrix. Every square matrix can be expressed as a sum of skew symmetric matrix and symmetric matrix, where these conditions are possible if or where symmetric part is equals to A plus A transpose by 2. A matrix, if A matrix A is given, every square matrix can be written as a sum of symmetric and skew symmetric matrix, where symmetric part is equals to A plus A transpose by 2 and skew part can be symmetric part can be written as A minus A transpose by 2. If symmetric part can be written as A plus A transpose by 2 and skew symmetric part can be written as A minus A transpose by 2, then every square matrix can be written as a sum of symmetric and skew symmetric part. Okay, so by this we can write the sum as a square matrix. So what is the condition for a square matrix? Just sum, skew plus symmetric. Okay, then A minus A transpose by 2 plus A transpose by 2. We will get A minus A transpose plus A transpose by 2. Cancel out 2A by 2. What we will get? A. That's it. As a sum of A can be written as a sum of symmetric and skew symmetric. That's it. This is the most important point in matrices chapter. Now the another most important part is a orthogonal matrix. What is that? A square matrix can also be called as orthogonal matrix. Orthogonal matrix. A square matrix can also be called orthogonal matrix if the condition is A transpose is equals to I, or the another condition is A transpose is equals to A inverse. A square matrix is also called a orthogonal matrix if A transpose is equals to I or A transpose is equals to A inverse. Okay, A transpose is equals to I and A inverse is equals to A transpose. These are the two. If these two conditions satisfies, then a square matrix is also called a orthogonal matrix. Next, the condition is a square matrix is also called as singular matrix. A square matrix is also called a singular matrix. if the condition for a singular matrix is simple condition det A is equals to 0. If det A is equals to 0, then square matrix is also called as singular matrix. Okay. Next, for non-singular matrix, a square matrix is also called as non-singular matrix. Now we had seen for singular. Now it is non-singular matrix. The condition is if det A is not equals to 0. If det A is equals to 0, a square matrix is called singular matrix. If det A not equals to 0, a square matrix is also called non-singular matrix. Then we will jump to our next formula or next point. Okay.